Lesson 4.1, graphing polynomial functions. We're also going to get into some vocabulary involving polynomials as well. So, polynomial functions. A monomial is a term, right? So if I have y equals 3x, right? This is a monomial because this is one term. Okay, if I add to that, right, now it becomes a binomial. So each term is called a monomial. A polynomial is a monomial or a sum of monomials, all with positive exponents. You have to have positive exponents for it to be considered a polynomial. So here we have it kind of laid out for us in function notation. A is that leading coefficient. And then we have our various x to different exponents. The highest exponent is called the degree. And then whatever gets added at the end without a variable is called the constant. So in standard form, your exponents are going to go in descending order from left to right. So biggest exponent to smallest exponent. We have different types of polynomials. Degree 0, it's called a constant, right? So we see an example of it on the far right, right? So f of x equals negative 14. That would be considered a constant, right? It's going to be a flat horizontal line. We have linear polynomials or linear functions. Those are degree 1. We see again our example 5x plus or 5x minus 7, right? We have that x to the first power, so that is a degree 1. The leading coefficient there would be 5. We have quadratics. We have lots of experience with quadratics, right? That's a term to the second power plus a term with the x to the first power and then that constant, right? So here we see 2x squared plus x minus 9. It has those three terms that are all being added or subtracted. The exponents are in decreasing order, right? X to the squared, x, and then constant. We have cubic functions. Those would be of degree 3. And then quartic are degree 4. So in our first example here, we're asked to determine if it is a polynomial function. So for it to be a polynomial function, we have to have positive exponents. If it is polynomial, then we're going to be asked to write it in standard form, tell its degree, its type, and what its leading coefficient is. So looking here at example A, right? Looking at example A, negative 2x to the third plus 5x plus 8. Right? So this is a polynomial, right? Yes, it is a polynomial because it has all positive exponents. So going forward, we need to write it in standard form. Well, it already is in standard form, right? We have our exponents are in decreasing order going across from left to right. We need to tell its degree. This is a degree 3 because its highest exponent is 3. What type then is that? Well, that would be a cubic. And its leading coefficient, just abbreviate that now for LC, is negative 2. Right, so that leading coefficient, just like when we were looking at trinomials, is going to control the polynomial, how it is flipped around the x-axis. Looking at example B here, negative 0.08x to the third plus square root of 2x to the fourth minus 8. Is that a polynomial? Well, we look at the exponents, right? We have all positive exponents, so yes, this is a polynomial. Okay, so we're going to go through, write it in standard form. So g of x, we need our largest exponent, this 4, to be the first term. Square root of 2x to the 4th minus 0.8x to the 3rd minus 12. So there's our standard form. This is a degree 4 because our highest exponent is 4, which would make that a quartic. And its leading coefficient then is the square root of 2. Looking at C, negative 2x squared plus 7x to the negative 1 plus 4x. So this right here disqualifies it from being a polynomial. Right? It has a negative exponent. Polynomials have to have only positive exponents. And here, in example D, k of x equals x squared plus 3 to the x. Again, this is not polynomial because it has a variable in the exponent spot. So here in example 2, we are asked to evaluate a polynomial function. So they say f of x equals 2x to the 4th minus 8x squared plus 5x minus 3. Right, so all we are really doing, then it says when x equals 3. So we are finding f of 3. Right, so we're using the f function, and anywhere we see an x, we're going to sub in a 3. Plus 5x. Again, anytime we see an x, we sub in that 3. And then we're just going to use order of operations to work our way through this problem. So right, this will be 2 times 81. Right, and this would just be calculator work. I would evaluate 3 to the 4th. It's 81 minus 8 times 3 squared is 9. And then plus 15 minus 7. Right, and as I work this through, I will just start simplifying this down. Right, 81 times 2 is 162. 8 times 9, negative 72. And then this, I can simplify this, right? I can get plus 8. So then I would just work it out and plug that last part into my calculator. Right, so that's pretty simple. You could type this into your graphing calculator and go to table, scroll to when x is 3. I don't know that that's worth the effort. Talking about end behavior, the end behavior of a function is the behavior of the graph as x approaches positive infinity or negative infinity. For a polynomial function, the end behavior is determined by the function's degree and the sign of its leading coefficient. Right, so they all follow this pattern. Right, if we have an odd degree, that's the top part of our graph here. So odd degree polynomials. If your leading coefficient is positive, your end behavior kind of follows this pattern. Right, so positive coefficients as x approaches negative infinity, negative, or f of x or y, your y value is going to approach negative infinity. and as x approaches positive infinity, f of x also approaches positive infinity. For your negative leading coefficients, it's opposite, right? So as x goes to negative infinity, f of x goes up to positive infinity, and as x approaches positive infinity, f of x approaches negative infinity. For even degrees, right, all even degrees, 2, 4, 6, 8, etc., they follow this pattern down here. Right, if it's positive, remember we talked back in the previous chapter about positive gives you that smiley, negative gives you frowny. That works for all evens, right? So positive leading coefficient, smiley, negative leading coefficient, frowny. Ultimately, you do not need to remember this. You can use your graphing calculator and determine what that graph is doing as it approaches positive or negative infinity. That's the beauty of having that powerful tool. So if for a moment ignore that I put that solution check on the screen, right? We could think this through, right? My degree 4 is going to follow that even pattern, right? And it's a negative. So negative frowny, negative infinity, negative infinity. You don't need to remember that, right? We have access all the time to a graphing calculator. So you can see that as x goes forever to negative infinity this way, right? F of x, your output goes down. As y approaches positive infinity, f of x still is going down to negative infinity, right? So we can use that graph and rely on that tool more than memorizing the table. What you need to understand is what is end behavior mean. As x approaches negative infinity and positive infinity, which way is the graph headed? Lastly, graphing some polynomial functions. Again, we're just going to rely on our powerful graphing tools, right? We're going to use our graphing calculator, either the TI or Desmos, to get some data that we need for the graph. For that first function, I can type that in as f of x. I can also just type it in as y equals, a little quicker, right? So it was negative x to the third plus x squared plus 3x minus 3. Right, so we get an idea of our graph here, and then I'm just going to record some points, right? I have a point, looks like I have a point right. So I'm just going to start recording some points. So I have negative 2 comma 3. I have a point here at 0 comma 3. Right, I'm just going to steal some data. And then I would then use that data to construct my graph. So I knew I had a point here, here, so it came down. Ooh, that's not very good. So it came down, loop back up. Right, so you're just stealing data from your calculator to build a graph. Looking at our second example then. I have y equals x to the fourth minus x to the third minus 4x squared plus 4. Right, give my equation a quick glance, making sure I have everything typed in correctly. And then I can go to the graph and start stealing data again. Right, so I have that intercept there. I have a point that's almost at -1, -2. I have solutions here and here, and a minimum there. Right, so some of the data that I had was -1, 2, 0, 4, 1, 0, 2, -4. And then I can use those to kind of guide my graph. Came in, looped up, back down, hit the minimum, looped back up. Right? The more precise you need to be, the more points you're going to have to graph. But again, end behavior here, right? As f of x on this first one, as x approaches negative infinity, f of x is approaching positive infinity. This one here, as x approaches positive infinity, f of x is going to negative infinity. Right? The end behavior for example B over here, they're both going up to positive infinity.